All right. So our first talk today is going to be Terrell Russell and myself, and we're going to be talking about iRODS delay server migration.
All right. Thank you, Mr. MC. I love it. Hi, I'm Terrell. We're going to talk about what we added to 4.3. Some of this is in 4.2, but not all of it. So this hopefully will be new to you and very exciting. We've been designing this for a couple years and now it's actually released. So the delay queue in iRODS is the way that we do stuff later, right? In iRODS, you can run rules right now with like the iRule command. Rules can be fired synchronously because of policy. If something happens through the API, you've got code that's in the servers that can fire synchronously because of certain things happening. And then the third option is because you put something in the delay queue to fire later. So this is a refactoring, a rewriting, a reimplementation of how that mechanism works. So I'm going to talk about the mechanism and then talk about what we've added and changed to it. The queued rules are really just rows in the database. So there's still a single source of truth. This is not necessarily a distributed system. We don't have some kind of consensus algorithm. We don't have to worry about, this one running it and then this one running it and then oops, we ran it twice. This still is in a transactional relational database. There are rows in the table in the database, and they're processed by the iRODS delay server in a priority order. And in theory, everything behaves and it's nice and clean. Most of the time, the delay server is asleep because its job is really only to go get the rules out of the database and then either run them or give them to their friends to run. It wakes up by default every 30 seconds to find work and then goes back to sleep again. So far, so good. That is not necessarily new. That's all the way it's been. So here's the architecture. This is the first time we've ever made a picture for what the delay server is and does. So on the left, you've got the queued rules that are just rows in a database. The iRODS delay server is a child process of the iRODS server. And you heard yesterday about the kind of new restart capability, the cron-like facility that we added. So if the delay server went away in the past, sorry, you probably have to restart your iRODS server to get it back. That's no longer the case. So it is a child process. It's mostly asleep most of the time. The way that it works is it runs a query against the catalog. It pulls out the rows, pull out. It gets the results of the rows whose time have come based on the query that it's running. And it keeps them in an in-memory set in its own brain, right? In its own process. It then has in threads that can run in parallel to process the jobs in the in-memory set. And it's doing that with an implicit remote, and I'll talk about that in a second. And that implicit remote now will farm out those jobs in a round robin fashion today. If anybody has opinions about a better algorithm or a different algorithm or how we can do that, happy to talk about it. Right now, it's just round robin to send those jobs back over to other iRODS servers. This is different, and I'll talk about that in a second, from what happens in 4.2. When any job completes or errors, it removes it from the catalog and then removes it from its in-memory set. And it does that in order because we want the transactionality to take precedent, right? It's also important to do it in that order because every 30 seconds, regardless of how long the jobs are running to take to run, that query is being run again, and it might pull the same job out of the database again. But because it's a set in memory, we basically dedupe on the insertion into the in-memory set, right? It just doesn't go back in there again. So it's important that we remove it from the catalog first and then remove it from the in-memory set so we don't get that a double spend, right? A duplicate execution. It's also important to understand that this works because there's only one delay server in the zone, right? If you had more than one delay server and they're running the same code, they're going to get the same results because they're going to run the same query. We don't want that. So there's only one delay server in the zone. This is important. Can you see the colors on this projector? Yes. So you got red, blue, purple. Totally made those up. They're not really important. The colors aren't important. What's important is that each of these sections of how the delay server functions has a setting in advanced settings where you have a little knob to change what's going on, right? So we've got how long it sleeps. By default, it's 30. Maximum size of delay queue in bytes. We're not measuring the number of rules. We're measuring the amount of memory. We're limiting the amount of memory that the delay server uses while it holds the in-memory set. And that's because rules can be huge, right? We don't know how big they're going to be. So it's not done by the number of rules. It's done by how big they are. And if they don't fit in the set, they come back in the query, but they don't make it into the set. They'll be in the next one, right? The query is going to run again in 30 seconds. So far, so good. The third knob is how many, well, what's your concurrency level? In the past, we were limited to the number of processors on the machine running the delay server. But because we've added this facility for this list of executors, that list of executors can be other iRODS servers in your zone. So coupled with the implicit remote, even if your machine only has 24, 32, 40 cores, you can make that concurrency. I don't know if we tested this. It's a bold claim. You can set that concurrency to 400, 450, 500. If you've got other machines who are willing to help and take the load, right? Because you're going to have 450 threads, but most of them are just going to be waiting for it to come back from the other machine. So they're basically going to be asleep and not doing anything. That's up to the OS to handle that. But we don't think there's a bottleneck in terms of chewing through your work that's in the delay queue. On the right here is kind of the history of how this happened. So 425 was 3 years ago, something like that, 3.5 years ago. So this has been a process of iteratively refactoring these pieces and adding the functionality we needed. Before, the way it's done now, it was a process model instead of a threaded model. It just didn't scale the right way. There was actually the design of the algorithm of how it pulled things out of the queue and processed them had a couple bugs in it, and they would block themselves. And so we've refactored all of this. There are no known limitations or bugs right now in this implementation. Famous last words, right? If you find them, let us know. Like I said, it's round robin right now for the list of executors. If that's not efficient or good, maybe random is better. We can talk about that. Maybe it's a utility function to find out who's loaded and send it to the other ones. Because it's an implicit remote call, you don't know where it's going to run. If that matters, where your code runs, then use a remote in your delay. And then it will go to where it needs to run, right? It's now using the query processor library. The rule context is now stored in the catalog as a 429. That was important because before that, those REI files were written on the machine. So if you ever wanted to move the delay server, the context is on over there. So that was a problem. So now it all lives in the catalog. And then with 4.3 came the restart capability, the cron, to make sure this thing is always running. And we added the implicit remote and the targets for that. The design goals behind all of that. Oh, no, sorry. So for the migration process, remember I talked about the fact that there's only one delay server. Okay, well, what if you want to move it? Okay, now you've got concurrency, you've got things coming out of the catalog, so you got to manage all this. We don't want to have the same machine, the two different machines running the same code because they're going to run the same code. We don't want that. So we have to figure out how to move the delay server without a restart to a different castle, right? We need to move to a different machine because it's old, because it's time for somebody to be upgraded, because whatever reason, right? Because it went away and it's not coming back. It's too late already. It's already burned down. So no restarts required is a design goal. We can't have the double spins. We can only have a single delay server in the zone. We want this to be relatively hands-free because by the time you're having a disaster, you don't need another one. Let's just make it easy for you. And then, of course, we want this to be able to be interrogated. We want this to be able to, you have to be able to see what's going on in order to understand. But there are a number of moving parts, so that's a tricky one. The approach that we came to is we're going to lean heavily on the transactionality of the database. That's our source of truth. That's been our story for a long time. No, we're not going to MongoDB. We can't do that. We have to have the transactionality to do iRODS well. So we already have that. Let's lean on it. We're going to use that to keep the source of truth. we're going to split the role of the leader and the successor. And that was due to the fact that the same code is running on all the machines. They have to be able to determine what role they want to be in and what they are in and navigate the handing of the power to the next one, right? So means that different servers are going to run the same code, but come to different conclusions. So we have to have 2 different code paths, which means they have to have 2 different hats to put on. So we're going to store that in the catalog. We want all the servers to run identical algorithm. We don't want different code on different machines. It's too complicated. So they are each responsible for their own behavior. They have to decide whether they are the leader and to do that work. They have to decide whether they are the successor and how to promote themselves, right? We're not going to reach out and tell somebody what they're doing. They're all running the code and they decide themselves. In the configuration for this, it's 2 rows in the grid configuration table. Define who the leader is, define who the successor is, and those are just host names. So that's how we hold it. Everything else is in the box. This is a demo. See, I just did it. This is what holding it looks like. When you get the delay server, this is the interrogation part. Who is the delay server right now? What's the status of the delay server situation? You're going to get back leader, hostname, successor, hostname. Those just came out of the catalog. Very straightforward. It's just a JSON payload. There's one way to hold this. You run iadmin set delay server to the hostname that you would like the delay server to be. What that does is put that entry into the successor row in the database, not the leader row. And then you ask the system, you see it in the successor, wait a few seconds for the algorithm to do its thing, and then it has promoted itself and now it is the leader. Again, because this is transactionality, all these servers are looking at the database for the truth. They're going to see this at exactly the same moment, and nobody gets confused. Nobody stands up a delay server that isn't supposed to. There's only one at a time. All the design goals are met. This is the algorithm in fake Terrell code. This is what I handed to Kory before he made it real. It's brilliant, right? So on the left, if I am the leader, remember every server is running the same algorithm. If I'm the leader, my job is to decide whether I should continue to be the leader. So if a successor is defined and it's not me, my job is to finish my in-memory set. No. My job is to finish the currently running in threads and let those jobs finish. Then gracefully stop caring and go away. If that is not what's supposed to happen, then I need to start. I mean, I'm the leader and I don't have a delay server. I need to start one. I need to get to work, and then off it goes, right? This algorithm is not doing the work. This algorithm is deciding whether or not the delay server is running, and that's it, okay? If I am the successor, then my job is to see what's going on and figure out if I need to promote myself to king, right? So I run a health check on the leader, whatever that means. If the leader is not running, well, then it is my turn. I don't stand it up right now. All I do is update the catalog and get out, because I'm going to run this algorithm again in a few seconds. And at that point, I'll be in the first part, not the second part. If the leader is still running, then I save that health check information for later, and then I'll come back around in a few seconds and we'll do this again. And after a while, eventually the health check will decide, well, he's super dead. And then we go into the first part, right? If I am neither the leader or the successor, my job is to get rid of any of this situation that might be running on my computer. I'm not supposed to be part of this, right? The only place the algorithm touches the database is upon promotion. So there's only one way to do this from the outside when you set the delay server, and there's only one place in the code that touches the database, and that's to promote. And everything else happens independently on their own merit. And this is how Kory is going to tell the story of how that went when he took my pseudocode and made it real.
Right. Okay. So making this work took quite a bit of investigation. For one, like a lot of this code, is not something that we always have to touch, right? Going into the main server is pretty, solid. But some of the interesting things that came up with this was that, in order to make this work, we need to be able to figure out how to make one server detect, is the leader, the current leader, down, because we don't want overlap with delay servers, right? Because they don't know about each other. They could pull rules from the delay from the catalog and operate, execute these rules multiple times, right? And so we don't want that to happen. So some of the things that we did is that, we have this cron manager, right, which was actually one of the intern projects from last year. So that's great, right? So we were like, well, yeah, we have this thing. So let's go ahead and let's move the delay server code, the fork process for the delay server, into a cron test, right? And so now we have this situation where we can now detect when the delay server is like available or present and things, right? At least that's the idea. But this presented some problems, because one of the things we encountered is that when we started looking at how to do this communication, the server would lock up, and we weren't sure exactly how this, what was causing this, right? And so instead of actually going deeper into trying to figure that out, we were like, well, it would be nice if we could actually distinguish the actual control plane logic as a separate process, right? So let's fork the control plane, and then people can look in the process list and actually spot the control plane process. So we do that. We spend all this time and we write all this code trying to migrate that out. And turns out that we run into a new problem, which is we now don't know who our parent is. So we can't look at PID information and say, oh, I am a child of the iRODS process. And so now we're back. We have to roll all these things back and come with a different approach. And so what we did was we started looking at, after some pondering and things, we realized that, oh, the cron manager is actually running inside of the main server's loop, the main loop. And this was a block. All the things that happened within the cron manager were blocking calls. So the minute the request to ask the network, is the leader running a delay server, that would cause an agent to be forked, but it couldn't, the agent could not be forked at that point, because we sent the request across the network and to the server, and it can't respond to itself because it's all in the same process. And so basically, the way we solve this is by moving the cron manager logic into a separate thread. This also informed us why the control plane itself was already a separate thread in the first place, because the control plane also needs to respond to PID information, right? Because if you're running a delay server, the control plane is actually responsible for tearing the delay server down and reacting to signals and various different things. And so that was something that we learned with this process. Another thing that we encountered with the delay server was that, let's see. So that actually might be the biggest issue, was that the lockup was it was difficult to detect and react to. But through all this work, we actually were able to implement some additional facilities in iRODS that were helpful around, like, we were able to make the process add a PID file that allow iRODS to run, as an actual single instance on a system. So we can enforce that now. And so people can't launch multiple delay servers on the same host. So some good things did come out of this. Yeah. So one other thing that we also learned was that the database itself, the main iRODS server process actually does not have database information or connections available to it on startup. That's something that's only available in the agents. And so we had to figure out, well, how do we get the main server process to know how to connect to the database. And so there's a whole journey around like, well, how does that happen? Is this safe? Is it safe to make this API call here? Is it safe to tear it down here? And so once we were able to figure those things out and track it down, we were able to make all that stuff work. And so when the main server has to figure out, you know, am I the leader or the successor, we just, you know, we're able to open connections and things and tear those down in a clean fashion. This also means that if you're running on consumers, one of the things that we have to solve is basically handling of database credentials. The provider always has database credentials, right? Because that's where all the machines are always redirect. But for consumers, they don't normally have database credentials. And so to make this work, if you wanted to move your delay server to a consumer, you also have to add the database credentials to that server as well. So currently, that's something that we want to go back and look at and move that, make the logic where it's that, you know, you don't have to specify database credentials on all the machines that you know, want to move your delay server to. We like to have it where it's that the delay server can just be, you can say, set it on this machine, and I don't want to have to share my credentials across the entire cluster of iRODS servers, right? So yeah, we want to remove the database credentials requirement. And also we need to, you know, implement some settings to control sleep time between migration algorithm runs, because right now it's just hard coded to 5 seconds. So every server, if you have a large network, large cluster of iRODS servers, all these servers are going to reach out to the database every 5 seconds and just ask the question of, hey, am I the successor? Am I the leader? And this happens, you know, this will happen in 4.3 quite a bit. That's something that we also need to measure and spend time on to decide on whether that's a good, how bad, what's the effects of all these servers asking this question. We also want to detect and skip a redundant implicit remote. And that's mostly that's the biggest challenges that we experienced during this process of implementing this algorithm. All right. Yeah, I think that's it. Yeah, any questions?
Yeah, I have a remote question from Ton. If he's here, if he wants to ask it, he can, or I can go ahead and state it. If an executor crashes, will the delay server detect it? So on executing a delay rule, if something crashes, will the delay server?
So if it doesn't complete and it doesn't error out, it won't go back to the database, which means it's still in there for the next query to pick it up. And it will still be in the in-memory set, which means that it will still be available for execution the next time. So I think the answer is it shouldn't matter. It should recover from that. Unless the fact that it's already been grabbed out of the in-memory set. How does that work?
Well,
Maybe.
if a connection, if a rule is executing and the agent crash, that is no different than a client like iCommand, than one of the iCommands crashing, because the delay service is just going to establish a connection to either one of the other iRODS servers that's listed in your delay rule executors list, or to itself. So the worst that will happen is that the rule is not removed, although, you know, because it's just a connection, like there's logic around the connection handling that, you know, will detect that the agent disappeared because the connection just went away, right? The socket is no longer there. And so that's something that we actually do react to. And most likely, as Terrell said, the rule will probably exist will continue to exist in the catalog, because we don't know what happened on the far end, right?
Maybe. Not sure. I think the question is, what happens in the in-memory set? Does it, who removes it if it doesn't ever finish? or is it already owned?
If the remote executor fails, the executor running within the delay server will detect this failure, and
Oh,
I
and then report that.
believe it would behave as a normal failed
Yeah.
delayed rule.
I think that's true. That
I'd
sounds
have to double check that.
Any other questions?
good. Mr. Constable.
So what happens if the database that's marked as the primary is off, shuts down, server dies, whatever? Does it auto migrate, or does it need an admin to run the command to set the new master?
If the database is gone,
No, sorry, the server set in the database is the primary.
if the server that is set to leader
Yep, leader. Sorry, yeah.
goes away,
Yep.
then that would be that would be detected by the health check as part of the successor part of the logic. If you don't have a successor set, then you just don't have a delay server for a while anywhere, which isn't a problem. Your delays just won't be firing. They'll just pile up for a while. And then responsible sysadmins will notice this and stand up a delay server somewhere, and then the work should continue. Nothing should be lost. Nothing should be double spent, so to speak. I think it's just your delays will be more delayed.
So it would need manual intervention at that point, is what I'm hearing.
Right, because if you set the delay server into entry,
Yeah.
then you have kicked off the handoff of power, right? You've kicked that off. I suppose there's a place perhaps for the successor, the on deck, in case of fire, promote yourself to successor. That's a possible scenario that we could think about and how that would work. But right now, yeah, it would require, your delays would just be more delayed until a human comes and makes the computer turn back on.
I want to ask, you're asking about if the leader disappears, right?
And doesn't come back.
And doesn't come back.
Yeah, it's super gone.
Hmm.
And they're- and-
It's going to come back at some point in the future, but you have no idea. It's gone at 2 a.m. and everyone's asleep.
Yeah.
I believe we added logic that, in this logic, we check, if we know we're the leader, we're already the leader, there's no migration going on. We check to see, we have the PID information, right? So we can check that and say, if there's no delay server here, launch it again, just run it.
On the machine that should be running the delay server. But if that machine is super gone,
Oh,
nobody's hitting that part of the code.
okay.
And they won't until it comes back 4 hours later because somebody restarted the machine, or until that same human runs set delay server to a different machine.
A follow-on question for that then is, how do you recommend doing a check in an automated fashion to say, is the delay server is it up?
Right.
Is it running? That kind of
So
thing?
that's what grid status sees the delay server PID, reports it.
Yes.
Yes. So the iRODS grid status, that's two different. Can you hear the hyphen? Will report the PID of the delay server appropriately. If there is no PID, if it's not running, it shouldn't be there anymore because of the PID file advance that happened.
So you need to be running that on the server that should be running it, if that makes sense. You need to be running it on.
No, as long as it can. If the machine is gone, it's not going to answer the grid status.
Yeah.
That can be a clue.
It can be a clue, but from an automated thing, that system's, if my mental model, the system has still got that server set as the, I want to say master, it's not the right term.
Leader, yeah.
Leader, thank you. So it's still set as the leader. It was running the delay server master, so it's got a setting in the grid because it's that's what it's set.
It's only in the database. That's right.
Yeah. But that server's now gone away. So as a, in agile terms, as a sysadmin, how can I determine that the server that is somewhere in my iRODS zone that is running the delay server is actually up and is actually running the delay server that is supposed to be compared to the data? You know, there's a whole series of
Yeah.
checks.
I think the grid status is the answer. And if somebody's not responding, that's your clue. Because if they are responding and they say, I don't have it, well, then wait a few seconds. It should wake back up because of the restart stuff, the cron. And if the machine's not responding, it's not going to answer the question. So I think that's your information. And if it does answer and it does have a PID, well, then you're good.
Yeah. So you could run a Nagios or whatever check on every single host that says basically delay server status, which checks, am I the delay server?
That's
And
right.
if so, am I running a delay server?
I think that's the idea. So the only new scenario here, I think, is that you want an even more hands-free in case of fire scenario.
Yeah.
Promote to successor so it'll promote itself.
I think it's more just understanding that situation. 'Cause as
Sure,
you say,
sure.
The worst case is that nothing happens until somebody starts it up. But I think you need a way for a human to go, what's the problems in the kind of thing right now? Oh, look, you haven't got a delay server.
That's
you
right.
need to sort that out.
Yeah. And this is also why we don't introduce this kind of stuff unless it's 0.0, because we want to give people a chance to break it in new ways. But yeah, all the thought experiments that we have so far, I think, are handled. And I think we've got the interrogation pieces available, but there may be new facilities that we need to make it cleaner and easier as we see this work in the real world.
Can I suggest then that maybe a consortium in general comes up
Yeah.
with a kind of a standard Nagios monitoring check or something, just
Sure.
as an example for this?
Sure.
I'm happy to work with people on that one, but I haven't got for free yet.
Yep. Makes sense.
All right. Well, we should move on.
One more question, if I can,
Uh-oh.
if there's time.
There's actually not time, but maybe we can talk about it.
Very good. Thank you.
Thanks.